So what's our next rule then? Our next rule says convert adverbs and pronouns into times, places, people, and things. So if we have a sentence like this, everyone loves the Macarena, we want to convert that into a standard form categorical statement by introducing a standard form quantifier, introducing a subject term, picks out a class of things, a copula that's consistent with the quantifier. We've got a non-standard verb, so we're going to fold that into the predicate class, and we get all people are people who love the Macarena. Here's another one. There's nowhere to hide from logic. Here again, nowhere, got to translate that into a place. So we've got no places are places to hide from logic. So again, hiding pushed into our predicate term. Lots of sentences have unexpressed quantifiers. They don't explicitly tell you how much. And so when we have that, we've got to add a quantifier that makes sense in the context of the content of that sentence. So suppose we have a sentence like this: computers are indispensable. So we want to stop for a minute and think to ourselves, well, not every computer is indispensable. That old 8086 that Dad's got hidden under the bed there, that's not indispensable. So it's probably not going to be all. Instead, maybe I'll try introducing some computers are indispensable. And again, I need a class of things, so I put things in. I could put technology, I could put devices, and so on. How about this one? Air guitars are not instruments. Okay, so now we have to ask ourselves, are some air guitars not instruments, or are all air guitars not instruments? Probably the best answer is no, air guitars are instruments. What's our next rule? Our next rule says non-standard quantifiers must be translated with standard quantifiers. So in other words, there are lots of quantity expressions in our regular language, but in our formal language, in our categorical logic, there are only 3. And so we have to try and cram all of those quantities into an appropriate quantity in our formal language. So for instance, many people like hockey. Well, many isn't one of our quantifiers, so we're going to have to change it in a way that's consistent. So if many people do, at least one does, and so we're probably best off by saying some people are people who like hockey. All people are not hockey fans. Here we have a standard form quantifier, but it's got a non-standard copula. It's not consistent. And so we have to ask ourselves, do we mean some people are not hockey fans, or do we mean no people are hockey fans, or do we mean all people are hockey fans? Probably the best interpretation of that sentence is some people are not hockey fans. The next one is even more tricky. So if we have a conditional statement, that statement isn't really relating classes. It's relating the truth of the antecedent to the truth of the consequent. It's a propositional sentence. However, we can oftentimes translate a conditional statement into a standard form categorical statement if we identify the antecedent clause and we say all members of our antecedent clause are members of our consequent clause. So for instance, suppose I say, if you work hard, you'll get ahead. Or I say, if pigs fly, Bill will pass this course. In both cases, I can identify the antecedent of these conditionals and the consequent of these conditionals. And so then I can translate these sentences by using my universal affirmative quantifier, followed by a term that picks out a class of things that describes the antecedent clause, followed by my standard form copula that's consistent with the quantifier, followed by a predicate term that picks out a class of things consistent with the consequent clause. So I'll end up with all hardworking people are people who get ahead. All flying pigs are indicators the bill will pass this course. So again, these interpretations are a little forced, but if it's important that we translate it into categorical logic, they work. Next one's very sort of picky. There's a phrase called the only, and Hurley tells us replace the only with all and change nothing else. So for instance, the only good homework assignment is a finished homework assignment. So now, using our rule here, we say, okay, we're going to get rid of the only, replace it with all. I don't reverse the terms or anything. I keep them in the same order, and I get the following translation. All good homework assignments are finished homework assignments. The next one is called an exclusive proposition. Exclusive propositions exclude something from a general class. So none except Wallace is having fun. None but the brave enjoy logic. So each of these exclusive propositions is going to have an exclusive phrase. Hurley tells us take that exclusive phrase out, substitute in all, and switch the terms. So we'd get something like this. All people having fun are people identical to Wallace. And all people who enjoy logic are brave people. This next group is acceptive propositions. Acceptive propositions express a general rule and an exception. And so Hurley says, let's translate those with two sentences, and gives us some examples of phrases that introduce acceptive propositions. So all but, all except, and few, he says, are good candidates as acceptive propositions. So for instance, few believe in Clinton's fidelity. All cats except Bill will sit on your face when you're asleep. So again, we're going to use two sentences to translate these. With few, we know there's at least one in each case, so we've got a rule and an exception. So some people are people who believe in Clinton's fidelity, and some people are not people who believe in Clinton's fidelity. With our Bill the cat example, no cats identical to Bill are cats that will sit on your face when you're asleep. All cats not identical to Bill are cats that will sit on your face when you're asleep.